Hello everyone. This is Natasha from the NextWork team here. I hope you're having a good day, and I hope you're all excited for this amazing project that we are about to go live with. So a bit of context for today's project. This is part 4 of a 4-part 3-tier architecture series that we've been putting together over the last month now. And if you are ready to become someone that is familiar with what 3-tier architecture means, how you can build your own 3-tier architecture web app, this is the project for you. So thank you so much for joining me, and let us get started with the project. All right, so as you can see here, we have our project guide right in front of me now. This is called Build a 3-Tier Web App, and the description, which is what we're going to be doing today, is build a scalable web app with S3, CloudFront, Lambda, API Gateway, and DynamoDB. A big shout out to everyone that's in the chat already. To Azam that says, hi, where can I find part 1 to 3? You can find that in our YouTube channel. These are all existing streams that maybe I can even link to you now. Is there any way I can link you to that existing stream? Let's see if I can. All right, so I'm gonna find the existing stream and I'll link it to you in the chat now. So thank you so much, Azam, and here you go. All right, so what you are going to, for anyone that can't find the stream and you're over in Instagram, just know that it seems like I can't post comments to Instagram right now, but you'll have to just find NextWork on YouTube, and you'll be able to find the live tab, and then you'll find all of the previous parts in this single video over here. Or you can click into the videos tab and be able to find the first 3 parts, which are fetching data with AWS Lambda, creating an API with Lambda and API Gateway, and then you can also find the very first part, website delivery with CloudFront, all over here. So please enjoy the first 3 parts, but if you haven't done the first 3 parts, you can absolutely still do this project in one go. Just know that this is a pretty packed project, because we're going to be doing the first 3 parts, and we're going to be doing some additional linking to put everything together in this final piece. So thank you so much, Sai, for saying looking forward to the new project demo. That's super sweet. Veer Basant is saying excited to do this project. Thank you so much, Joe. We do got this. And Marzena, always a joy to see you. So let's get started now. Now, 3-tier architecture, if you're still new to the concept, is a way to organize web applications. So 3-tier architecture is a way where you can divide an app into 3 different tiers, so you can manage different parts of an application separately and then link them back together so they work as one fully functioning app. Think of it like a layer cake. We have a top layer, which is called the presentation tier, and this is what the user sees and interacts with. So for a web app, which is what we're going to be doing today, the presentation tier is truly the website that you're hosting that students can see, and the presentation tier will be for example, the HTML files, the JavaScript files, the styling sheets, the CSS files, so that you're putting together, okay, what should the user see? Where should the text go? What color should things be? What should happen when the user clicks on this button? Now you have the middle tier, which is the logic tier. Now the logic tier is like the brains of your app, and this is where your app is going to be processing data. So let's say a user clicks on a button in your web app. In the back, in the logic tier, maybe you have a function, you have a process that says, okay, user clicked on button, I should create a new user using some of the details that they've entered into this form. Let's sign up this new user. That's something that you will have to process in the back. What's something else that you could do? Maybe when you want to transfer some money, in the presentation tier, you're putting some clicks around like dollar amounts that you want to transfer, which account you want to transfer from, you push send. And the moment you push send, how does that money actually land in the other bank account? So the logic tier is where there's a lot of there's a lot of work being done to process some of the things that you're doing in the front end, in the presentation tier. Can anyone else also think of another example of the logic tier? Do share it in the chat. All right, and then we also have the bottom layer, which is the data tier, and this is a tier that stores the data in a database. Well, the logic tier, you can think of it as kind of like the gears, the processes that keep things moving. But let's say a user just signed up to your platform. How do you keep that user's data? I don't think you'll be able to just keep it in a process that should be consistently running and processing new things and new transactions. So that's where the data tier becomes very, very handy. So the data tier stores data in a database, and that data will be used throughout your app. It could be user data. Imagine if you have like an e-commerce web app, then you would have a huge database of product data. So that's where the data tier comes really, really handy. Now, we have done 3 individual projects on each tier of the 3-tier architecture. We've done a project on the presentation tier. Look up website delivery with CloudFront if you haven't seen that yet. We've done a project on the logic tier, and that was when we created APIs with Lambda and API gateway. And then we did a project on that final tier, the data tier, which is fetching data with AWS Lambda. But really fetching data, this part, the really key service there is DynamoDB, and that is the database that we were using to store user data. So if you're starting this project without doing these recommended projects, we'd suggest giving yourself at least 4 hours to do this one. It is a pretty chunky one, but you can absolutely do it. I think the more challenging and the more difficult something is, the more rewarding it is to actually feel like, oh, I did that, at the very end. Sanish asked a very great question here. Is this beginner friendly? And yes, it is. Okay, I know the difficulty here is hot. We put hot as our difficulty level today, but that's mainly because there is a lot of work to go through. But in terms of the technical challenge, we're going to be doing every single step together in this live project demo. So absolutely, it's beginner friendly, and you can always ask any questions you might have in the NextWork community. All right, so we've talked about the presentation tier, what the user sees, and that's what we're going to be doing first in this project. We're going to be looking at setting up an S3 bucket that's going to store some of your website's files, your web apps files. And then we're going to use CloudFront to distribute that website. So CloudFront distribution basically means how can you make your website spread out across the world so that users around the world that wants to access it can load your website in a very, very fast, in a very, very short amount of time. And then we have our logic tier, and that is our Lambda function over here that's doing the processing of some data and for our web app. So what the user is going to see in our presentation tier for our website is they'll be able to look up a user's ID and then be able to see that user's information. So you can think of it as a great web app maybe for internal company use. Maybe you have some admins that want to look up user data based on a single ID, and this is what the web app's going to do for them. So that Lambda function is going to be that key function that helps actually grab the ID that your user searches up in your website and then retrieves all of the relevant user information from the DynamoDB database. So API Gateway over here in the middle is here to help you with connecting the two. API Gateway, you can think of it as kind of that link between your website to Lambda function, so that when you click on something, it first goes into the API Gateway, and then your request turns into API Gateway formats your request into like saying, hey, Lambda function, can you do this for us? A user wants to look up user data. Then Lambda function is going to say, all right, gotcha. A user wants to look up user data. Thank you, API Gateway, for giving me the user ID that the user has put in, that the user wants to look up. Let me now grab this and go to DynamoDB and retrieve all of the data that we know about this user from the database. So that's our data tier at the end. And yeah, with that, you have your presentation tier, your logic tier, and the data tier. In this project, we're going to be doing all 3 parts, and then we're going to be doing some special work to link it all together. Okay, so that's a quick recap of what we're about to do. First of all, we need a storage bucket for your website's files. All right, so can you find that here? Yes, we can. And then we're going to distribute your content globally with CloudFront. Can you find that here? Can you find CloudFront? I hope you can. Here you go, CloudFront distribution. All right, build the brains of your application using serverless functions with Lambda. Can you find that in our architecture diagram for today? You should be able to find it right here. That's the Lambda function. So we're going to be doing that next. And then we're creating an API to handle user requests with API Gateway. Can you find API Gateway here? I hope you can. It's right here, pointing at Lambda function. So that's what we're going to be doing after the function. Finally, let's store and retrieve some user data using DynamoDB. All right over here. Cool beans. Finally, oh, I just realized I said finally twice. Finally, we're going to connect all of these services together for your 3-tier architecture, a fully functioning solution. All right, I hope everyone's just as excited as I am. This is super cool. And Joe says, lately my brain has been on a delay ever since New Year's Eve, so things are a little tricky for me. I totally get that, Joe. I feel like this project's gonna wake us right up. Me included, oh my goodness. Okay, we're gonna be selecting the high-touch version of this project, which means we'll be going through every single step together, including every single click, every single change in the code. And if you're ever stuck, please ask the NextWork community. Students like you are already asking questions about this project. They're already trying to do each part of this 3-tier architecture. So use the most out of the NextWork community. It is one of the best decisions you could do when you're looking for support, when you're wanting to share a project you've completed. Great shout out to Kai as we get started. I'm locked in now. Oh, that's really cool to hear. We'll get locked in together. Will you guys be putting up a repo for this project? Great question. The project guide is the best place to go to for now, and the YouTube live stream will be saving all of these streams on our YouTube channel, so I would recommend going there first. All right, and for everyone that says the link says page not found, I'm going to investigate why that is in just a second. We're going to take a quick pause while I have a look at what happened to the link in the project guide, and I will see if there's anything we could do. Ooh, good question. Thank you so much to everyone that says the link is not found. That is so funny. I think I know exactly why. So let me just update the link right now for everyone that's finding this project over YouTube. And let us get started in just a minute, everyone. Thank you for waiting. Okie dokie. I'm about to send the updated link in the chat so everyone can see. And if anyone else in the chat is still looking for the link later in this project, I'm going to make a big request that you guys please send them this link if they're still looking for it. Okie dokie. Cool. I think we can get started now, team. All right. Thank you to thank you to the viewers over on YouTube asking if we can change the orientation of the video. We're looking into that, I promise you. And the recording will be on YouTube under the live tab. Cool beans. So let's start with step 1. What are we here to do today in this exciting new project? So in this project, we will demonstrate how to set up a 3-tier web app from scratch. I'm so excited, everyone. And what we're going to do is we'll start with the presentation tier, then set up the logic tier, and finally set up the data tier before tying them all together. Great stuff, everyone. We'll click done for our very first question complete. Yay! Now let's set up the presentation tier. All right, team. So recap of our strategy: presentation tier first, then the logic tier, then the data tier. Let's get started with the first tier. This first tier is responsible for displaying the website to our users. So in this step, we're going to create an S3 bucket to store our website's files. We're going to upload a simple website file to our bucket, and then we're going to make it accessible to the world by setting up CloudFront to deliver our website's content. Cool beans. So for the presentation tier, we will set up how our website will be displayed and available to our end users. All right. This is because the presentation tier covers our website's files plus website distribution. And can you tell which service is responsible for which? All right, so the presentation tier is responsible for storing our website's files. And where are we going to do that? We're going to do that with Amazon S3. And then after that, what about website distribution? Who's responsible for that? Well, that one will be our very handy Amazon CloudFront. Okay, so I'm going to select done, and that's our strategy for the presentation tier. So let's head on over to creating that S3 bucket to set up the website's files. What we're going to be doing is we're first going to be creating the S3 bucket, downloading some files that we've already prepared for you, storing them into S3, then going over to CloudFront to say, hey, I have some website files over in my S3 bucket. Can you please distribute them or host them so that users will be able to see it as a website and not just like a random index.html file. And once that's done, we'll be able to see a distributed website. Let's do it, team. Okay, so we're gonna first log into the AWS Management Console as your IAM user, please. So in your console, we're gonna start by going into, you guessed it, Amazon S3. All right, team. And then we're gonna click on Create Bucket and enter a unique bucket name. All right. So let's click on Create Bucket and let's enter a unique bucket name. So please make sure your bucket name is completely unique, because in the entire world, regardless of which region you're in, every single bucket needs to have a completely unique name. So let's put in NextWork 3 tier, add your name, Nat, for example, and add some random numbers like 1 to 3. Actually, we can say live demo 1, 2, 3. Okay, and then we are going to go straight into selecting Create Bucket to finish creating the bucket. Okay? Cool beans. Now, this project does assume you have some experience with S3 already. If this is not true, you're like, hey, I'm actually kind of new to S3 too. Well, you can always check out the live project demo for the first project of this series, which goes through everything with a bit more detail. So I'd recommend doing that, and then coming back to this when you're ready to put it all together. Okay, so we're clicking into our S3 bucket now, and we're ready to upload our web apps website files. Okay, So let's download some existing website files that we've prepared for you. So we have a HTML file, which is the main file for a website. It's where you organize the text, pictures, everything that makes up your web page. And then style.css, the second file over here, is where you write down the visual appearance of your website's HTML elements. So HTML is kind of like, I'm going to be putting in some text here, an image here, a button here. Style.css is where you write down the visual appearance. Can my paragraph text be font size 12? Can you use this family's font, this font family? Can you make my button pink? Can you hover something? Can you make my button hover or like bounce when you like hover over it? So that's how index.html and CSS works together. And of course, we have a JavaScript file which adds interactions, like making sure that when you are refreshing your social media feed, that new content loads in. So, let's actually download those files. I just realized we've talked over it. But we're going to save our HTML file. And if you're feeling unsure, like you don't have access to these files, you want to set up something, you can absolutely always create your own files, because I'll be showcasing the contents of each of these files in this project demo as well. Cool beans. Okay, so once we've downloaded the files, we need to verify what we've downloaded. We need to go into the downloads folder in our local computer and open up index.html in our browser. So let's verify that we've downloaded something correctly by, again, going into the downloads folder. So I have downloads open over here. These are some old downloads, so you can ignore that file. And then right-click on index.html, select Open With, and then open with your browser. So I'm going to open with Google Chrome, because that's the browser that I'm using. Pick the browser that works best for you, and ta-da! So we can see that there's a web page in front of us right now, which confirms that, yes, we do have an index.html file that is displaying content correctly. And since that there is some styling, like a color for the buttons, the placement of the buttons, like the spacing between them, we can see that style.css is showing as well. Our JavaScript file, you can't really confirm that until you actually have some interaction or the logic tier set up most of the time. And so we won't be able to confirm this until later. But we do have our index.html file confirmed. That's the most important one. So let us confirm that we see a simple web page, and then upload the files next. Now, if you are a pro student, if you've tried creating static websites before, you might ask an amazing question, which is, am I setting up a static website right now? The answer is not quite. Whether a site is static or a web app depends on where code is being run. So static websites over here, they don't need to communicate with any backend cloud resources. There's no database. So code or logic is all run on the client side. It is simply a work of your browser loading your index.html file and the style.css. Web apps, on the other hand, they need to run code on the server side. So apps that use databases, like an e-commerce site, Amazon, where you can buy things and there's a database of products, where there are APIs or Lambda functions running in the backend, that's going to be a web app. So far, we don't have any of these three set up. We will later. So right now, technically, you could say it's a static website. But by the time we set up all these three additional parts, the database, the API, the Lambda function, absolutely, it becomes a web app now. Okay. So we have the files downloaded, and we can now upload them back into our S3 bucket. So we're going to open our S3 bucket, and we're going to select Upload. You can choose whichever button. Add the files, and select the 3 files that make up your website. Okay. And then we're going to upload it right now. Great work, everyone. So we have successfully uploaded 3 files into our S3 bucket. So we can safely close this tab, but I'm going to double check. Now that these are uploaded, you don't even need to close that right now. You can actually go straight into your next service. So we're going to go into CloudFront now, which is our content delivery network. Okay? So exciting news, we have website files in our S3 bucket, and we're now moving into the world of CloudFront. So are you familiar with CloudFront? Are you familiar with the concept of a content delivery network? If no, we do recommend going in a more slower pace with the first project of the series. But you can absolutely still do this. You can absolutely still create your CloudFront distribution from scratch in this project too. Cool. So with CloudFront, we're here in the Amazon CloudFront console. Amazon CloudFront is a content delivery network. So as a recap, that means that it speeds up the distribution or the way that you host your website content, like your HTML, your CSS, your JavaScript, and the image files that make up your website. So you can even add this little new definition. And if you're new to using NextWork, let me demonstrate how you can do this. So if there's ever a paragraph that you want to expand on, you can highlight the paragraph and select Simplify. And look at that. It'll be able to simplify a paragraph that you want to learn more about, and then give you a deeper explanation. Cool beans. So how is it that CloudFront actually speeds up distribution? It uses a very, very cool technology or a cool process called caching. And caching is a process of storing copies of a file in a cache, which is like a temporary storage location, so that in the future it can be accessed more quickly. It's kind of like how you can have supermarkets, but also maybe like convenience stores, and it's a very loose comparison, but it's the first one that comes to mind. So you have supermarkets, which are like big markets, big storage spaces for groceries, but you can always go into a little convenience store and get something that you need that's already there, that's already been, it's already been stored there, and grab it quickly because it's just around the corner from your house. Caching works in a very, very similar way. So we've stored our website files in an S3 bucket. Think of that as like the supermarket, the main storage location, or like the big hub where our website files are being stored. But then CloudFront, what it does is it makes a copy of those website files you've uploaded into servers around the world. So it grabs your content, it makes a copy in New Zealand, a copy in the US, a copy in Canada, a copy in Nigeria, a copy in India, a copy all around Europe as well. You can imagine that because of that, when your users around the world want to get access to your website, their browser can just quickly get access from that server that's close to them. Okay, and because of that, their request doesn't have to travel all the way to your origin S3 bucket anymore. Now, because of that, content is being delivered with the best possible performance. It's just getting delivered to your browser in a much faster way. Now, for smaller websites like what we are creating today, maybe there's a small difference between using CloudFront and not using CloudFront. But how it becomes very useful, imagine if you're like Netflix and you have millions of content that users are trying to stream like all the time. The new season of a hot TV show just released. So many people are going to try to get access to that, to every single episode. So how can users get access and still stream in a very, very fast way when traffic is so high? And that is how CloudFront can try to speed up distribution. Now servers around the world can make a copy of the really hot series or that movie that a lot of people are going to watch, so that when users around that server want to watch that series or watch that movie, they'll be able to stream it in a much faster way. Okay, so with that spiel about CloudFront and distributions done, let's create a CloudFront distribution. Okay, so we have an origin domain, and we'll be able to select our S3 bucket. So NextWork 3-tier live demo is our S3 bucket. And then we'll be able to go into entering a name for this origin, which is our NextWork 3-tier architecture S3 bucket. All right, very, very straightforward. Let us add that into our name. Cool. So now we're on to origin access. And this is something we go into a lot more detail when we are looking at that first project of the series. For this project, we're going to be using a faster route that requires less troubleshooting. And we are going to go straight to changing the setting from public to origin access control settings. Do you remember what this does? So this setting helps you to restrict access to your bucket so that only CloudFront can get access to your bucket's objects. If we had kept this public setting, do you see what this subtext says? Bucket must allow public access. So if we had kept this setting at the top, it means an S3 bucket must allow public access to the entire world for CloudFront to be able to access the bucket's objects too. But maybe you know now, public access isn't quite the best security setting that you can be using for your S3 bucket. So let's set up a more secure way to do this by using origin access control, which means your bucket will have to can block out everyone else in the world, but let in just CloudFront so that CloudFront can still grab the website's contents and again, distribute it around the world. So we're gonna be using origin access control settings. And you might notice that I do have some already, but this is because I've done this project before, okay? What we're going to be doing is we're going to be setting up a new one from scratch, okay? And then we're going to create a new origin access control. So this one will be called, just keep that default name if you'd like. There's no need to rename it. And you can go straight into creating it. Cool beans. So I'm going to select create now. Okay, cool. And before we move on, notice that it says we need to update the S3 buckets policy too. So CloudFront will give you a policy statement after you create this distribution, and you need to copy that policy statement and paste it in your S3 bucket settings. We're not there yet because we need to create the distribution first. But once you've created it, get ready to go back to S3, update its bucket policy settings so that it's blocking out everyone, letting in CloudFront, and off we go with distributing the website, seeing a distributed website. Nice work, everyone. So I know that there are so many settings that we're scrolling past right now. Just know that these default settings that are being selected for you is great for a basic website we're distributing. It's more that these additional websites are great for front-end developers, are great for application developers who really want more ways to distribute their website or ways to handle the way your website is getting distributed. We don't need to go into the details of these because you can still see how CloudFront works without having to understand each of these separate parts. So worth a dive into it if you want to know more, but it's not required at all. Okay, and when we get into a web application firewall, just make sure you're selecting do not enable security protections so that you're protecting yourselves from any potential costs, like $14, as an estimate for 10 million requests a month. Let's just not enable security protections for this project, just to avoid charges. All right, so let us scroll all the way down to the default root object. This default root object is basically saying, now when someone visits your website URL, where do you want to take them? Which file should open on their browser? So here we're going to be saying, which file do you think? Which file should be loaded onto their browser? Do you remember what we did to test the files we uploaded? Well, what was the file that we tried to open? That's right, the file we tried to open was the index.html file, which means that when you want to select a specific page that a URL should direct users to, you can absolutely refer to the HTML file's name. Okay, so let's select index.html here. And let's create our distribution, all right? Cool beans. So we've created our distribution now. Do you think you can actually go into the distribution's URL and just be able to see a functioning website straight away? Let us actually click into this link, the distribution domain name, and try open it up. Oh, the site can't be reached. Oh no, what's happened here? It even asks us to check for a typo. So no, we haven't quite figured things out yet, and that's because we still need to update our S3 bucket settings. We're going to need to make sure we've updated that policy in our S3 bucket so that it's still allowing CloudFront to access your bucket's files. Okay, so we're going to need to select copy policy over here. Okay, and fly over to our S3 bucket so that we can go into its permission settings and edit its bucket policy. Let me enter the bucket policy now, save our changes, okay? And what this means is our S3 bucket now has a policy which controls access to the objects inside the bucket. So the policy says, "Dear S3 bucket, please block out access to everyone except for CloudFront and this specific CloudFront distribution." So your S3 bucket is going to say, okay, no one can see my bucket's objects except for the CloudFront distribution. And so your CloudFront distribution is so happy now. Yay, I have access to the website files that make up a website I need to distribute to the world. So CloudFront grabs those files from your S3 bucket, and what does it do? It distributes it to the world. How does it do that? Well, it does it by making a copy of those website files into separate servers around the world. Okay, so let us refresh our CloudFront URL and see if anything's changed. There we go. So as you can see, our CloudFront URL now is showing the index.html file that we uploaded. Isn't this so cool? This has confirmed that the files we uploaded into the bucket are functioning. We have set up a proper connection between S3 and CloudFront, and of course, CloudFront is set up in the right settings that enables us to see a hosted website when we visit the link. If you'd like, you can even try to visit the website link now. I've just put it into the chat, or if you can't see it, this is the URL. So you will have to go, okay, this is quite a complicated URL to be copying. But if you happen to have the powers to copy this down, you'll be able to see this file I just hosted with CloudFront. I just distributed with CloudFront, which is called http://d3tbqgj7m4 8eu6. Interesting URL name. .cloudfront.net. I'm going to be deleting everything by the end of this project, so if you're seeing a replay of this project, you might see that this URL isn't working anymore. But for everyone that's tuning in live, that link should be working. So let me know, does it work for you? And a big shout out to everyone over Instagram. Thank you, Andrea, for saying hello. We have some questions. This is so funny to see. Harsh is saying, I fancy Azure. Why am I here? Because these projects are so much fun. And yet Neil is awesome. Great foresight in saying, aren't we going to allow CloudFront in S3 permissions? And we just did with the origin access control. Thank you so much for saying that. This is amazing. I hope you enjoyed this project. And hi to Lucy watching from the Philippines. Isn't that cool? Yay! Amisha confirms the link works. You can see the distributed site. And isn't it crazy? Before, you wouldn't be able to see it. In fact, Amisha, since you're here, why don't I delete my bucket policy so that those permissions are absolutely wiped now? And do you want to try refreshing the link again, Amisha? Do you want to see if the link would still work? Ideally, what's going to happen is you're going to refresh the URL. Oh, and actually, the link is still working. Aha, I just tricked you a little bit. Why is it? How did the link still work even though the bucket policy has been removed? So this is something else that comes through with CDNs, and it's a bit of a tidbit that I'm adding into this live demo. So something that happens with distributions is sometimes it takes a couple of hours. It can take a couple of hours for changes to actually be propagated into all of the servers where there are copies of your website files and copies of your website setup. So what's happening here is when you've made a change to the access settings, not every single server in the world that's made a copy of your file is going to be able to respond to that. Because what if that server had a setting that just said anyone that wants to access these files should get it? Okay, so Amisha, what's happening here is maybe the server, that CloudFront has made a copy, where CloudFront has made a copy of your website files, the server that's now serving you that website content is still giving you access, even though the source, our very source, the S3 bucket has blocked access now. Okay, so overall, what this means for us is you would actually sometimes need a couple of hours in order to see changes in bucket policies propagate out to all of the servers that CloudFront is distributing your website content with. Anyway, I'm gonna save the changes back. All right, and then we're gonna keep on going. Okay, so we have done all of that. We've verified our CloudFront distribution, and we can take a screenshot of the website loaded through CloudFront. Are you ready? This is quite a fun screenshot to be taking. The first time our website is distributed. Great work, everyone. So it says, how did you access your website? How do we access the website? We access our delivered website by visiting the CloudFront distributions URL. What do you think we could say next? This distribution URL is working because we also set up an origin access control that lets our S3 bucket restrict access to only our CloudFront distribution. Is there anything else you could say? If you like, you can say for context, stored the website files in the S3 bucket. So when a user is visiting the CloudFront distribution URL, what happens in the back end is, someone is grabbing maybe a copy of the website files are being allocated to a server nearby the user, and then the user's browser is loading that copy of the website files so that they're able to see our distributed website. So there's many different ways that you can explain how you could access your website. This is the more, technical, permissions-heavy way, but you could always explain it in the perspective of what's happening to the traffic. It goes from the user over to the S3 bucket, or it goes to the user to the server that's close to them, and then a copy gets sent straight to their browser to load. Up to you. Okay, so that was step 1 done. How did you find that step using CloudFront? I hope that was clear. If you have any other questions about using CloudFront and S3, you can always add it to the chat or in the comments section or in the NextWork community. So with our distribution done, tick, we can now move on to building the logic tier. So this is where the magic really happens. The logic tier is responsible for handling the brains of our application. Okay, so fetching data from a database, performing calculations. In this project, we're going to be using a simple Lambda function. Okay, and that's going to be the one that is really processing what happens when a user tries to look up user data. Then we have API gateway to handle requests and route them to the right place. So Lambda function is kind of like the worker, okay? And API gateway is like the messenger. So from the distributed website, which is exactly this, let's say I want to look up the user ID 1. Oh, nothing's happening. Okay, we can't seem to get any user data. So what's happening now? Well, we don't have any of this set up right now. So naturally, when we try to get some user data, nothing's showing up. There's no user data to show. There's no Lambda function to process your request. There's no API gateway to grab the request and pass it to Lambda. So that's why we need that logic tier to go from your distributed website. You click a button, the request goes to API gateway processes that request and passes it over to Lambda function to look for some user data. Okay? And this is another way you can visualize what we're about to do in this logic tier. So we have the user who makes a request. The request heads into the API gateway, and we're about to set up two resources within the API gateway that joins together to let your request get to Lambda. Okay? Cool beans. So for the logic tier, we will set up a Lambda function to process requests, e.g. look up user ID to return some user data, and also an API with API gateway to process user to receive requests from the user and hand it over to Lambda. All done. So let's create that Lambda function now. This function will be fetching some data from a database and return it to the user. Such a common use case in web apps. Where's another use case for grabbing some user data or grabbing some data in general and giving it back to the user? Can you think of another one? All right, so let's go into the Lambda console. Here we are in the Lambda console now. Looking good, everyone. And if you're new to Lambda, just know that Lambda is a service that lets you run code without needing you to manage any computers or servers. Lambda is going to do the management of those servers for you. And something that's great about Lambda is, because it helps you run code without needing you to manage like EC2 instances, without needing you to manage like any Kubernetes clusters, any containers. You can just simply say, can you please run this code? And Lambda function says, yeah, sure, of course. And Lambda functions are great for connecting with other AWS services too. So we'll be able to see that in the works by connecting it to API gateway and connecting it to DynamoDB. So some reasons why people love Lambda. It runs code only when you need it to, so you're not paying for any idle time. Now that means that when it does run code, maybe the cost of processing that single request might be more expensive than if you just managed everything yourself with an EC2 instance. So as you can imagine, when you're just setting things up as a beginner, or when you're just creating a web app that's not going to get millions of requests a month, a Lambda function is a great choice. if you're getting into that stage, maybe setting up your own EC2 instances is the better bet in terms of cost management. Cool. So, you can always scale Lambda from a few requests a day to thousands per second. And if you were managing all of your EC2 instances by yourself, maybe it won't be able to respond to changes in requests that well. That's why this is another reason why people love Lambda. Okay, so are you at the Lambda console now? I'm gonna give everyone another quick minute to get to Lambda. And in the meantime, thank you so much for everyone saying hi in the chat. GP Tech, really appreciate the support, saying that you've learned a lot from these projects. We also have Andrea asking a few things about IAM, and this isn't related to this project, but Andrea, one of the main differences is really the ability to manage a lot of different user accounts at scale. So organizations is truly great for maybe situations where you have huge teams to be looking after, like maybe tens, hundreds of people, thousands of people. Whereas IAM is really, really good when you have just a few users to create and you don't need to manage too many people at once. Organizations is also, I think, actually, organizations isn't quite about user creation, actually. It's more about creating AWS accounts. I just realized I had mixed that up with another service. So look into that. If you can definitely create user accounts into all, you can create lots of different accounts under, and they can all be under an AWS organization, or within each account, you can create lots of different IAM users. So they're on completely different levels right now. You have AWS accounts, and then you have IAM users. So you would create the account first and then set up IAM users. You can think of AWS organizations as a way to combine lots of accounts together, but you don't really need to do that. This is only for like bigger, kind of wider company scale. I hope that helps. Let me know if you were looking for something specific there. And thank you so much, King of Zamunda, for saying hello, everyone, and Happy New Year. Happy New Year to you too, King of Zamunda. Nice work, everyone. So let's create our Lambda function now. And we're gonna select create a function. And then we are going to author our function from scratch because we're gonna provide you the code that that function is going to be using. Let's add in a function name, which is to retrieve some user data, and use Node.js, please, as the runtime. Now, if this is a bit fast and you'd like slower explanations, just know that second project in this series has you covered with a more in-depth explanation on each part of this, this step, which is creating a Lambda function and also connecting it with API Gateway. So we're gonna create our function now, and we're gonna go straight into writing the code. So let's copy some code for Lambda, and let us head on over to our code panel or our code source to paste that code in. So it's still taking a minute, which is totally okay. In the meantime, Amisha, you've asked a great question around, can you give more examples of when would we need to use Lambda functions and when do you need EC2? All right, so if you're noticing this error, that's totally okay. This is pretty interesting to me. I think I'm gonna give this a cheeky refresh. And in the meantime, let's talk about this question. So again, Lambda functions are great for smaller scale examples when you really need to, when you wanna set up like a smaller application that maybe doesn't have millions of users. Now, you might be able to identify different processes within an application where maybe some parts there's like a million requests coming through, lots of things are happening, and that part of the application you might want to use EC2 so you can give a lot of control around how those requests are handled and also the cost management of those processing those transactions as well. Lambda functions, though, are great for processes that maybe you don't want to set up entire EC2 instances for running because it's not happening that often. So when you're creating your own applications for the first time, Lambda functions are often the tool of choice because you get set up a lot quicker. It's also a lot easier to connect to other services with Lambda because Lambda has a special function of being event triggered. What that means is if you want to ever create an app that says, oh, when a user clicks this, send them an email, you can use Lambda to connect API gateway, which is like receiving the request, like someone clicks sign up and you want to send them a welcome email, you can connect to another service, I think called either SNS or SES. I can't remember the specific one right now, but one of those two will be able to help you with sending an email, to the user. So Lambda functions great for smaller applications, especially those that are wanting to connect like multiple services together. Cool beans. All right, team. So with that, I think I'm just going to double check if it's working now. And there we go. The code source panel is working now. And here we go. We can paste the code for our Lambda function into here, and we go through in detail what this code function does, what this code source does. I think I was thinking of a specific word that I can't recall right now. I think it's like code block. But what this code does at a high level is it grabs the user ID that the student, that anyone submits in your website, and it searches this user ID in the database that you connect your Lambda function with. In this case, it's a DynamoDB database, which is what we actually specify and specify explicitly in the code as well. Okay, so when you're ready, please note that your region is using a placeholder right now. So you will actually need to replace that with the region that you're using today, which is US+1 for this demo. And you can pick whichever region is closest to you. You don't need to switch to US+1 just for this. But I'm going to be entering US+1 because that's the region that I'm using. Okay, and we're going to finish up by deploying that code too. So you can select deploy, which is kind of like making this code like active, making this piece of code like runnable or usable by any other services that want to trigger it too. All right. Cool beans. So let's take that screenshot of our Lambda function code and let us move on to how we can connect our web app with this piece of code. Okay, glad to see that the deployment is successful. Let's add this screenshot into our project guide and answer the question here. The Lambda function retrieves data by looking up a user ID that the user enters over the web app, and actually, let's be clearer. The Lambda function retrieves data by looking up a user ID in DynamoDB. So how the code works as well is it's using SDK, which is a kind of a series of like code templates that you can use to use AWS services within your application. So in this case, we're kind of using a code template for DynamoDB that lets us very, very easily retrieve data using functions that's already been predetermined inside this template. Okay, and it's called the AWS SDK, and you can also learn more about that in detail in the second project of this series. Okay, cool beans. Is there anything else that we can talk about here? We can talk about SDK. We can talk about how the Lambda function gives you an error message if it can't find the user ID. So we can mention that too. So the SDK is used in the function code, so we can use the Amazon SDK. Okay, cool. So this is how we can say it. The AWS SDK is used in the function code, so we can use templates and libraries that lets us find the correct DynamoDB table and request data. Great work, everyone. So I'm going to select done for that. And let us, deploy that function and get into API Gateway. So as you can see, we've already deployed the function just now, a second ago, so we can go straight into the API Gateway part. I'm going to search out API Gateway at the top of my AWS console so that we can now set up an API that connects the web app, so the user using the web app, over to the Lambda function that's processing the user's request. Cool. So with API Gateway, what you're going to see is that there are many, many different options for creating that API. We're going to be selecting a REST API today. Okay. So as you can see, the REST API is over here, and it is a type of API that uses HTTP methods to interact with resources. HTTP methods is a pretty technical term if you're new to it, so just know that we'll go into it in more detail later in this step. But for now, just know that REST is a very popular API choice because it's simple and it can be used with virtually any programming language. And that's what we're going to be using today to set up that API that connects our user with the Lambda function. So the API Gateway, or the API, is responsible for grabbing the user's request when you select Get User Data and pass that request over to the Lambda function. Nice work, everyone. And if you're, again, new to APIs, you want a deeper explanation, please check out the second project in this series. Nice work. So configure the API. This is what we're going to be doing now. We're going to be creating that new API and giving it a few settings so that it is set up for working with Lambda. And how that starts is just clicking on Build next to our REST API and selecting New API here. Okay, so our API's name is going to be User Request API like this. And the endpoint type is going to be regional. So an API endpoint type is basically your API's availability. Regional endpoints are accessible within an AWS region, so that makes it great for localized applications because it just means that the API is available to clients in a very, very fast speed. It's a bit like CloudFront. But as you can see, Edge optimized for global applications are for global applications, and you also have a private endpoint type for internal networks. Okay, regional works best for us because they're deployed in the current AWS region. Now, I would say one thing to mention is you also notice that there's something called Edge Optimized APIs, which route requests to the nearest CloudFront point of presence. We can definitely use this option, but in my research, we have seen a few cases where students get charged for using Edge Optimized, so I'm just going to keep with regional here so that just to avoid any signs of costs. Okay, and then we're going to be creating that API now. And to clarify, what we are doing by selecting regional means that we're going to deploy this API within the region of North California for this project and the region you pick for you. So picking edge optimized would have been the option that makes the API faster in all the different regions that your users are based in. But for us, we're just going to be using the more free tier eligible option by picking regional. Cool, I hope that was clearer. So let's create the API and set up the API resource. So this API page is this big dashboard that gives you all the different things that you can create with your API. There's so many different words here on the sidebar, but please don't worry about them. We're going to be focusing on two key things here. One is called a resource, and the other one is called a method. A resource is kind of like a URL at the end of your API that helps you organize what different URLs will do. So you can kind of think of resources almost like folders for different parts of your API. In this case, we're going to be creating a resource so that we can add kind of like this folder for, okay, this is the functionality for searching up user data. Because what if your web app was huge and you can actually have multiple functionalities like, oh, look up user data, send, and another functionality, send email to user. That would be a completely different Lambda function, a completely different resource maybe. So we're going to set up that resource now. Okay. And for our resource name, we're going to select users. So what that means is we're going to have an API URL, and it's going to say /users. And now that API URL is going to be in charge of, let's say, in charge of passing user requests, for example, the user ID, over to that Lambda function that you've created so that you can actually look up user data. You know, that's what our users resource is going to be in charge of. Cool. So let's create our resource now. And then we're going to select the resource and then create a method, okay, within that resource. I know we're going at a pretty fast pace, and this is because this is just part 2 of this series that we're going through. So if you want that in-depth explanation around, you know, what is API gateway, what is an API, what are resources and methods, and can we do this in a slower pace, please check out that second project in this series. You can find the stream for that in our YouTube channel. Okay, so now we're going to be clicking into that resource, and then we are going to be creating a method. So methods are things you can do with your resource. We've created a resource that's kind of like that folder that says, okay, this is the folder for things I can do with user IDs or things I can do with user data. So we're going to do a method that says, okay, one thing you can do with user data is to get user information. So let us pick get here. But there are so many things you can be doing with user data. You can delete user data. You can add user data. You can also update user data. So there are so many different things you could be doing. But we're just going to be retrieving user data today. So that's the get method. Of course, our integration type, you might have guessed, is a Lambda function, because we're going to be integrating our API with a Lambda function so that requests that get to this API gets passed into Lambda. Cool. As you've noticed, there are so many different things that you can use to integrate with your API. So Lambda functions are not the only thing. There are many different services and places that you can send an API request to. Cool. So now that we've selected our Lambda function, we're going to make sure that the default region we select for the Lambda function is the region where we set it up. So where is this region? US West 1. That should also be the region where you've set up your Lambda function. So select that Lambda function. Okay, And you can click on create method right away to create your method. Cool beans. So we've just created a method within get. You need to redeploy your API for the update to take effect. That's cool. Good to know. So what that means is our API is not going to have this get method or this get functionality yet. We need to actually deploy that API first. Okay. So let us take a little quick pause and let's recap what are resources and methods in API Gateway. So we've just set up, okay, first we went to API Gateway, which is an AWS service that lets us create and manage APIs. We set up an API, which is a way for different services to talk to each other. So in this case, the two services that are talking to each other are your web app and Lambda functions. So what's next? We set up a resource within that API, and resources represent different parts of the API. In our case, the user's resource represents the collection of users and the things we can do with our user data. Then we set up a method. Methods define things you can do within that resource. Get is used to retrieve user data. Delete can delete user data, dangerous one. And you can use all of those different methods to set up all the different things you could do. Okay, so I hope that was clear, and let us just deploy our API and see it in action. Great question in the broadcast, added to the broadcast today. When we retrieve data, under which format is that data? Or which formats are supported for this API? JSON, XML? You can definitely set this up yourself, Mokri. And in this case, we're going to be using JSON, but you can also set up different data types. This is something that will be slightly more advanced. As you're going to see later, there's going to be something that API Gateway Setup can do to also manipulate the format of that data when you pass it to the next service. But we're not going to be doing that in detail. What we're going to be doing is keeping to that simple JSON data that we're going to be just sticking to the simple JSON data that Lambda is going to retrieve from DynamoDB. Sorry about that, I got tongue-tied. So let's deploy our API, and let us pick a new stage to deploy it to called prod. So different stages represent different versions of your API. Prod typically, which means production. Prod typically means the stage where users will be able to see a live version of your API. You could use a different stage like dev to say, oh, this is only an API that's only visible to the developers. You can also create a new stage for testing. This is a version of the API that's available to the developers and the rest of the company, so the entire company can test out this API before we put it into prod and let all our users use it too. Okay, so these are different stages that you can use, and let's go with prod. Okay, that's the most, because we're going to be deploying our API and making sure our users can be using it right away. So let's deploy it under prod, and let us head on to seeing that the deployment was successful. Okay, so as you can see here, we are entering a new page now. This is not the resource page we were on, this is the stage page. And in this page, you can see we have a stage called prod. We have an invoke URL, so this is a URL you can use to use that API. And lots of different parts, different pieces of information about this stage. Again, lots of information, just only focus on one part, which is the invoke URL. And this is the URL that gives a user access to, gives a user or gives an application the ability to use the API. Now, big shout out again to Abdul Rahman in the chat. Abdul, hello, hello. It's good to see you here. Cool. So we are now going to visit that invoke URL. So that is the one part of the API you really should be taking notice of, okay? So again, that is the URL where your API can be used. In real-world scenarios, developers would integrate that prod stage invoke URL into the live application's code, so users are using the prod version, okay, of the API. What that's going to mean is eventually we're going to have to update our website files to say when a user clicks on a button, invoke this API, so you're actually searching up the user data that the user has inputted. That's not for now, that's for later. It's a bit of a spoiler for later. But what's going to happen now when we try to invoke it now? Okay, so I'm going to try invoke it. I'm going to even add it to the chat if you'd like to play around with that URL. So this is the URL that's supposed to let you use the API. Can you use it? Oh, not quite. What if we did /prod/users, which was the resource that we created. We created the resource user, the user's resource, which is supposed to give us access to, you know, our user functionalities. What do we see here? Ah, interesting stuff. Cannot read properties of undefined user ID, cannot read properties of etc., etc. And that's because we don't really have a user ID that we're trying to look up with this API yet. So because of that, your API kind of freaks out and says, there's no user ID for me to look up. How am I supposed to work? How am I supposed to pass on this data over to Lambda? So it gives you an error instead. Try give that URL a go. Try to go /users and see whether you get the same error message. All right, so dang it, we haven't set up our DynamoDB table yet. That's okay, we're gonna get onto that next. That error, of course, because we haven't set up our DynamoDB table yet, we don't really have data that we can look up. All right, and the request itself doesn't have any data included in it. But that's okay. A lot of that is gonna get resolved in the next step over here with our data tier. Okay, so are you excited for the data tier? I am, I hope you are. And it's the final tier of our 3-tier architecture. So we've got our data stored in DynamoDB. We have a Lambda function that's available to retrieve. Oh, I just realized this is not showing the most updated version. So let me see if I can just show you the updated paragraph. Okay, there we go. We have it now. So in the data tier, we've got the website files distributed through CloudFront and a Lambda function that's ready to retrieve the data. So now we need to put our API to use. The data tier is where you store all the data that the application uses. Okay, so we've got the website files. People can see that there's a website out there. Right now, nothing happens when you click on it. Why? That's annoying, isn't it? Well, we have set up a Lambda function. That Lambda function should be able to grab user data for us if we click into this. We even have an API gateway, and that API gateway is going to get put into our application code so that we can connect the API to this front end, so that later on when someone types in 1, they click get user data, the request goes to API gateway, it bounces to Lambda, and it should grab the data, right? Well, what's happening now is we don't really have the data to give back to our user yet. We need to set up the data tier, put some data in there, and do a little test and see whether our API can actually retrieve the data we put in, and that will validate that our application is working. Cool. I hope you are ready to now set up the data tier with me. We are going to be creating a DynamoDB table right over here, and then we're going to add some user data into that table. For anyone wanting to know about reruns, absolutely, you can rewatch this video later. Do check out the YouTube channel. It's called NextWork to access it. All right, so for the data tier, we will set up a DynamoDB database that stores user data. This is because when we are using our API and looking up user data through Lambda, right now there is no user data to return. The data in our DynamoDB database will be, let me have a read of this answer and just make sure it sounds okay. For the data tier, we will set up a DynamoDB database that stores user data. This is because when we are using our API and looking up user data through Lambda, right now there's no user data to return. Oh, okay. Actually, let us just say this. At the moment, there is no user data for us to return to our web apps users. The data in our DynamoDB database. So the data in our database will get returned once we set up DynamoDB. Okay. All right, cheeky last part of that sentence there. The data in our database will get returned once we set up DynamoDB and connect it with Lambda. Good stuff, everyone. So let's select done for that plan for our data tier, and let's head into creating the DynamoDB table. So DynamoDB is our NoSQL database. And if you're thinking, what is NoSQL? Don't worry, we go into a lot of that in detail in other projects that you can look into. But a very, very quick and simple explanation for NoSQL is you can think of it as a very, very flexible way to store data. SQL databases are databases where you need rows and columns, and every single cell in every combination of the row and column needs to be filled in or has some sort of value, even if it's like null. With NoSQL databases, you can actually start to set up what if a row only is going to be storing a user's address, and then the next row is only going to be storing a user's name and email. The row after that, their login, the last time that they logged in. You have different kinds of data for every single user that you want to store without taking up too much space. The flexibility of NoSQL databases gives you that flexibility. And it's a great way to store user data. It's also a very, very fast way to retrieve user data, which is why so many games and social media applications use DynamoDB. In fact, I think a popular use case of DynamoDB is Coca-Cola and how they use it to actually store a lot of their marketing and user data there as well. Cool beans. So we're going to go into DynamoDB, create a table, and then give it a name. So let's go into DynamoDB now. All right, and we're going to create a table from here. I'm quite excited. Okay, so let us go into tables and create that table now. The name is going to be user data because yes, it's going to be storing some user data. And we're going to give it a partition key. So the partition key is the one column that every single row in your data is going to need to fill. It's kind of like, it can be as simple as, you know, the user ID, like it's a 1, 2, 3. You can think of it as almost like a row number because every single piece of data in your DynamoDB database or every single item in your DynamoDB table is gonna need to have this key. It's the one way and the key way that DynamoDB would use for searching data. That's why it's so important. Okay, so we're gonna enter user ID, enter that here. And yes, we're gonna be using a string as a user ID. So you can put in user ID is the name or a combination of name and number, anything you want it to be. So we can just go ahead and create that table right away. And then we're going to add our first piece of user data in the database once that's done. So let's create the table. And great question from Ankit in the chat. Is it the primary key? Good question. So if I click on create table, yes, like you can think of the partition key as the primary key, but you can say that the primary key is actually made up of two things here, and you can actually see that in the settings here for your table. Do you see how partition key is a part of the table's primary key, and then you can use the second part of a table. You can use a sort key to make up the second part of a table's primary key. We're not creating a sort key, so our partition key is the primary key, okay? They're one and the same. But if we had added a sort key, then the primary key would have been a combination of partition and sort. Cool. That would have made up the primary key. Thank you, Ankit. All right, team. Are we ready to keep on going with our DynamoDB database? Cool. So the partition key for my DynamoDB table is user ID. This means that when our table looks up data, it will look it up based on user ID. Then it can return all items, all data related to the item with that ID. Cool. So I think that's clear now. So the partition key for my DynamoDB table, or really our DynamoDB table, is user ID. This means that when our table looks up user data, it will look it up based on user ID. Then it can return all of the data or the values related to the item with that ID. The reason why I'm using specific words like values and item is because that is a bit of DynamoDB terminology. And the key thing to know here is you don't have to be too nervous about the terminology. Just know at the base level that the partition key is used for sorting and searching. Okay, so our table status should be active now, as you can see here. So you can click into your user data table, and let's add an item to that table. So let's add our first piece of user data. You can select explore table items, and when you scroll down, no items are here, so let's create the first one. Okay, the first thing we're going to do to create that item is we're actually not going to be using this I guess, more beginner-friendly form way to enter some user data, like, oh, let's put in the user ID as 1, and let's add that their name is Amisha. You know, let us actually use the JSON view and switch off DynamoDB JSON. Okay, so we're going to be using JSON to enter a piece of data and all of its values at once without having to go row by row, you know, and then fill in every single form field individually. This JSON version lets us just copy and paste a JSON block and do it in a very, very quick and efficient way, which is also used in real-world applications more often as well. Now, DynamoDB JSON is a version of JSON that tells you the value of a user ID, it's 1, and it can also tell you the type of data that it is. As for string, imagine if I had said, add a new attribute and let's make it a number, and let's just say days in system. So this is the number of days that they've been in the system for. And let's say they've only been here for 4 days. So what's going to happen in your DynamoDB JSON view now? And for number, days in system, the value is a number, that's 4. Okay, user ID, the value is a string, that's 1. We don't need to use that because this basic version, this traditional JSON, is used more, and it's also accurate enough for our use case today. So we're going to switch off DynamoDB JSON, and we're just going to paste this JSON example into the editor here. There we go. So we have a user ID of 1, we have a name for this called test user, and their email, test@example.com. So let me switch back to the form view. Can you see now that all of these fields are populated for me without me having to enter it manually? Isn't it so much easier if someone else says, oh, can you please add this piece of data into the database, and they give it to you in JSON, rather than giving it to you in maybe a list and you have to enter it manually. So one thing to notice is we didn't even have to add name or email as attributes for this database beforehand. We didn't have to say this database could also have a column called name, this database could also have a column called email. So the reason for this is because DynamoDB is schemaless. So you don't need to define rows and columns. It really doesn't work in a row and column way. I know sometimes I mention like, oh, each row should have this, just as a way for you to visualize it. But the best way to visualize DynamoDB is like little blobs of data in a big bowl. Like that is the best way to visualize it because it's not exactly rows and columns anymore. All right? One thing just popped here. So I was like, oop. But right back into the demo team. Cool beans. So because you don't even have to define like the rows and columns, it means that using DynamoDB is such a flexible way to store data. And that is one of the key benefits of using that NoSQL database. Okay, another learning for today. We're going to take a screenshot of that data item we're adding to the table, and then we can keep on going with connecting DynamoDB with the rest of our 3-tier architecture. Nice work, everyone. Oh, wrong button. I'm just going to click done here. Very nice. Nice. A shout out to Abdurrahman. Woo, so easy. We have Anisha asking, the primary key will be the combination of partition key and sort key, correct? And the sort key part is optional. So you only need to put in a partition key. The sort key is more if you just want a more advanced way of sorting and filtering through your data. Not required at all. Great question here again. What is a hash value? A hash value, I'm not sure how you picked up on this, Amisha. Where did you find the hash value in this project so far? But as a quick explanation, a hash value is another way for you to also ID like items in a database. So it is usually a combination of, it is usually something that is calculated based on maybe the placing of that table item mixed with like some of the table items like partition key and its values. But it's a way for you to, it's another way for you to give something an ID or something like an identity, and it's very, very helpful in algorithms. Now, I'm not the expert in hash values, so this might be best if if we talk about this in the community after this live demo as well. We can absolutely make it a post in the community. So thank you so much, Amisha. Phew. So that was a piece of data in our DynamoDB table now. And with the data tier ticked off, we're kind of ready to merge the 3 layers. Isn't that cool? It's been an hour and a half of this demo now, and on top of, Q&A time and demo time, we've actually managed to set up all 3 tiers. Well, almost. Don't forget to open up the gates between Lambda and DynamoDB. We still need to give Lambda the permission to read the items in our database table. So what this means is Lambda currently has closed off access to, DynamoDB has currently closed off access to other services to see our table items. So right now, Lambda currently can't actually read DynamoDB's this item that we've created here. So what we're going to need to do is actually go into Lambda and give it the permission to use or access DynamoDB data. Are you ready for that? I hope you are. So let's go back into our Lambda function now. And you can actually select configuration, so you can give it the permission for DynamoDB. So in our Lambda function, scroll to configuration, select permissions, and here we are at the execution role. Our execution role has a specific name that was created for us the moment the Lambda function was created. So here we are already at the place where we can manage, permissions for our Lambda function, and we're going to give it a permission to use DynamoDB. So let's click Add Permissions, attach policies, and select DynamoDB. Ooh, there's so many different options that we can pick here, but read-only access is really the one we need, because right now this function is only just trying to retrieve data. It's just trying to read data. It doesn't need full access, which would give the Lambda function the ability to delete data, add new data. It's not really what we're doing here for our function, so let's not give it too much access. Read-only should be fine. Okay, so nice work, team. We have DynamoDB permissions now for our Lambda function, so it has the permission to retrieve data. Okay, so I'm going to scroll over this since this is stuff that we've just talked about. And yay, permissions added. That finishes step 3. It means our Lambda function should be able to read DynamoDB table items now. And with that data tier ticked off, we're kind of ready to, merge the 3 layers. How are you feeling, everyone? We have just 2 more steps to go. One is to integrate the tiers, and then the last step is to validate a fully functioning application. So we're getting really, really close. I would say this is like the 75% mark of our project, and we still have about 25% to go. So this is all of the new content that this project is going to give you now. We're going to integrate the tiers, and we're going to have a few things to connect. I wonder, looking at this diagram here, can you tell what are some connections that we haven't made yet that we still need to make? What do you think? Actually, just one key connection is required here. What do you think that connection will be. Okay, so the key connection we still need to set up is going from our distributed website into API gateway. How do we make sure that when a user is clicking in this button, that API gateway is catching that request and passing it to Lambda? It's not even catching the request right now. There isn't any way that we kind of refer to our distributed web app inside the API gateway. So how does it know to find the request in our distributed site? Okay, so that's the problem we're going to try to solve in this step. Great suggestion by Amisha as well. So the logic tier and data tier, very, very good point. You know, the Lambda function we've set up, and the Lambda function does refer to the DynamoDB database, so there's a bit of a connection there already. But what we haven't done yet is we haven't tested that connection. So we're definitely going to need to test it and see it actually working to know that we have actually connected these two. But yeah, really, really good point. And the key one that we will set up is between the presentation tier and the logic tier, the top one. Cool beans. So let's get into it. So let's add some test data to your DynamoDB table. We're going to update a file inside our website files to make sure our app is actually referencing our API. And then we're going to try verify that data gets displayed on our website. So again, we have some test data that we can add to our DynamoDB database. We can also update our website files. Okay, this one. And then make sure that when we update the website file, we're now connecting our API gateway. So yeah, I know before I've kind of been referencing this as the connection, but what's truly happening is this connection is made by connecting these two, script.js, the JavaScript file that's responsible for interactions, connect that with our API. So once all three layers of our three-tier architecture are set up, the next step is to connect the presentation and logic tier. This is because currently there is no way for our API to catch requests that users make through our distributed site. Okay, we're going to need to connect presentation tier and the logic tier. Let's see how we can do it, shall we? Great work, everyone. So now let's test the API. We're going to get back into our API gateway console, and then we're going to copy the prod stage API's invoke URL. We're now like going back into things we did in step 2. Isn't that so buzzy? You know, all three parts are really coming together now in this step. So hang in tight. If there's anything that you're thinking, oh my God, I don't remember this. I know we just covered this in the last like 2 hours, but I've kind of lost track of things. No worries. This happens so often when you're doing something new for the first time. Trust yourself. Refer to the project guide again. Refer to earlier parts of this project demo again. And you'll be able to remind yourself why each part of this three-tier architecture exists. So here we are getting into our prod stage, and we're copying the invoke URL in the prod stage. Now again, the invoke URL is the URL that gives something the ability to use the API. So we need to copy this invoke URL and put it somewhere in our website files so that when someone clicks on our button, okay, we're invoking the API, we're asking our API to come out, and we're asking to use it. Okay, so we need to put that URL somewhere so that we can actually connect this button click with triggering the API and using it. Okay, so let's test whether our URL is working. So we have our invoke URL. Gonna put that in here. And the guide suggests append this to the end of the URL you copied. So we're now gonna go invoke URL /prod, which is already in the invoke URL. But we're gonna go /users, which is the exact resource that we're trying to use. And we're gonna pass through a user ID. Oopsie daisies. I can see that right now the API isn't working. I wonder if I've added the table items properly. It seems like I have, so maybe there's something that's not working right now. What do you think could be? Well, maybe something that we're gonna need to look into. Is it says the type error cannot read properties of undefined, user ID. So we're running into an error right now. I wonder what's causing this error right now. We should have the permissions. Lambda is allowing permissions. Our API setup does seem correct. Is there something to do with the API setup? Where is our API setup? Let's go look for it. So we're now in error resolution mode. So let's see how we can resolve this error that's just come up. One way that you can actually test whether the integration is working is by going into the test tab in Lambda. This is pretty cool. I know we haven't mentioned this yet, but it was in the third project of the series, so you can always give that a go. And let's say we want to test user ID is 1. Will this work? Would Lambda be able to find? It failed. It's giving us the exact same error. This is interesting. So something has happened here. That means even our Lambda function can't retrieve the data from DynamoDB. So what this means is it could be an issue with the way that we've coded up our Lambda function, or it could be an issue with the way that we've saved this data here. I wonder what it could be. Could it be... I wonder if this is because... I wonder if there's an error with the code. So I'm gonna look into the code now and have a look. So there was an error with the type, and I'm referencing the correct region here, USS1. And it should show me some user data, and the key should be user ID. And where this error is happening, it doesn't seem quite clear where it's happening, but perhaps it's happening at 9:48. So where could that be? Line 9. It could be here, team. Yeah, line 9, column 48. I just realized I should move this for a little bit so everyone can see. But yeah, line 9, 48. Seems like there's an error here by trying to get user ID. And you can see that it's because of that line, because in the error log, it's referencing 9:48 here as well. So there's an error trying to read our user ID at line 9 of this Lambda function. What could it be? I'm going to think about whether or not it's an error with how we saved our DynamoDB table. It is called user data, so the name should be correct. The region is correct. It is a string. What could be the reason that now we can't find? That now we can't recognize a string? Isn't this quite strange? I wonder whether we should be going into a previous project just to double check the code and making sure that the correct code is being used. Sorry team, I know this is a bit of a pause in our project, but I am very, very curious why we've run into an error here. So let's have a look. I think maybe I think I might know why. I think actually it could be an API issue. Let me try this thing. I think it could be an API issue where when we were passing the API and connecting it to Lambda, there might have been an error in the way I set up that API and Lambda connection. I think maybe I have missed something in the connection with Lambda. Let me have a look at this. Let's have a look at this together. API actions. Oh, method request. I have a feeling it might be the API connection with Lambda. Oof. And I've seemed to have lost myself in the integration request. Okay, so the integration request, it's not a proxy integration. And I'm wondering whether it should be. Because the code here tells us that it is a constant user ID event, dot query string parameters dot user ID. That tells us that actually the code expects us to pass the entire event, send the request to our Lambda function as a structured event. And the Lambda function is supposed to process the entire event by itself. But we had turned this off, which meant that the connection didn't expect the Lambda function to grab an event. It expected the Lambda function to just get a string that was the user ID. Maybe I need to turn this on. Save that. And retry this. Maybe that could solve our error. Not yet. We might need to redeploy our API for that change to take place actually. So I'm gonna deploy that API again. And while we're waiting for that deployment, thank you for this question from Mega. Are you live on any other platform? Yes, we are live on YouTube right now. So please come check out the YouTube channel called NextWork, where you can see the full screen for this live demo. Thank you so much. And hi to Mr. Fresh Boy J. Hello, hello. Good to see you. Alrighty, so our deployment is active for prod for this API, and let us refresh our API once again. And there we go, error resolved. So it turns out it really was the proxy integration that we ran into. And If you'd like a deeper explanation into proxy integration, just know that we talk about that in the second project of the series. But a quick recap is that proxy integration basically means that the event, which is, you know, the user clicking send user data, the user clicking fetch user data, okay, that event gets passed to the Lambda function. Otherwise, when we had turned it off, the API gateway was expected to grab the string itself, the user data string, and then pass that over to the Lambda function. And that actually would have been harder to set up than what we did do, which was just write the code in a way where the Lambda function processes the event itself. All that to say, one simple change in our settings solved that problem. And it ended up being an API gateway, not the Lambda function itself. That was quite interesting, wasn't it? Thanks for sticking through it with me as I resolved that live. And I'll make sure to update the project guide to reflect that too. So here we are using the prod stage API, and you can see that we're using the user's resource, and we're trying to look up, hey, can you give me all the data related to user ID equals 1? And our API says, yeah, of course, here's the data that I've retrieved. So this is a proof that our API and the data tier, so that is the logic tier and the data tier, is connected well. Great stuff. So let's take a screenshot of our API's results and update our project guide. So here we go. I'm going to just take a screenshot of those results, and let's answer this. To test our API, we visited the invoke URL of the prod stage API. This let us test whether we can use the API and retrieve user data. The results were some user data in JSON when we looked up user ID equals 1. This proved a connection between logic and the data tier. This proved a logic and data tier connection. I'm just going to be sneaky so I can fit into the word count. All right, so we're going to click done now. And let us view our distributed site. So here's the final, I guess, final test on whether or not we can see a functioning web app. What do you think? All right, get user data. Come on, come on. Ah, not yet. What's going on, team? All right, so you can actually go inspect your web page. And this is used by lots of front-end developers, actually, using the inspect tool to see what's happening on your website. And we are going to select, oh, I just realized we're skipping an optional question here. But yeah, what do you think is actually happening? Do you have any suggestions you'd like to add to the chat? Please do if you have a suggestion. Why do you think you're not seeing any user data yet? Maybe we're not seeing user data because, why do you think? Well, maybe we're not seeing user data because our API is not connected to our website yet. Perhaps that could be the case. All right, we're gonna select done, and off we go. So let us actually investigate what happened there. So where do you think your website is connected to your Lambda function? So let's find the console tab once we've started investigating our website. And look at that. We've got some errors in our console, which tells us that there are some errors with loading the functionalities of our web app. Okay, so we have an unexpected token. Oh, actually the really important error message to look at is a failed to load resource. The server responded with a status of 403. Oh my goodness. That means there is something for us to update to make sure that it can load the resource. What is the resource that's not getting loaded? Shall we zoom in and have a look? So as you can see here, the user ID, there's like a section that seems to say your prod API URL / users user ID. That's so confusing. Where do we even write that? Not that we really know of. I don't think we can recall a specific place where we've defined that. So let us actually get hints from the rest of this console, which is actually a repeat of these two error messages again and again. Okay, so just focus on these two. Right now, we can't seem to load this resource. Fair enough. It just says your prod API URL. It's not a proper prod URL. There's no way that actually takes anyone to a functioning API. So what's going on here is, oh, we have some hints in a reference to script.js. So let's check that out. So let's go into script.js. Let's open that file. And this is the script.js that we had initially uploaded into our S3 bucket. Okay, so look at that. Look at this funky little line here that is referencing your prod API URL and the rest of this URL that's giving us that pesky console error. Okay, so there's something that we need to fix here. So there's a line that directly references your prod API URL inside script.js. So what's actually happening? The error in my distributed site was because there was an error within index.js. Oh, sorry, script.js. One of the website files I had uploaded into S3. The script.js file is referencing a prod stage API placeholder and not my API and not my API's actual URL. So because of that, our website couldn't quite actually retrieve any data when we looked up a user ID. That's totally okay. Let us just select done. And let's keep on going with our project. So we still need to update script.js, and we're going to need to head back into API Gateway and make sure that our prod stage URL is actually inside our script.js file. Cool. I know that was a bit of information here, so we're going to pause for a second and say a big shout out to Michael, who says, Michael from Ghana here, learning a lot net. You're amazing. Thank you, Michael. This is a lot of encouragement. And please, if there's any way our project demos can be even better, don't hesitate to share that with us. Next, we have Dari saying good morning. And we also have Ola asking, what project is this? It is our 3-tier architecture project. You can find, for anyone saying it's too enlarged, and wanting to get a recording, please know that this is all available in our YouTube channel under the Streams tab. So please head into YouTube, search up NextWork, and search up our Live tab to see all of our live streams where this will be recorded too. Great work, everyone. So what we're going to do now is we're going to go into our script.js file, which is one of the files for our website, and then we're going to copy our API's URL to make sure our API is being referenced inside our website files. Right now, our website is not even referencing our API. The API's URL is not even in the website. So there would have been no way for it to actually grab the user data. Okay, so let's change that and let's update script.js. Cool. So we have script.js. Let's open it, maybe like this over here. Okay, and this is something that we'll need to update. This is our script.js file. And yeah, we definitely have something a bit tricksy here. We need to update that prod API URL with our actual prod stage URL. Do you still remember how to get it? You just simply copy the invoke URL inside the API gateway and make sure you're selecting stages and prod. Copy that invoke URL, paste that here. There we go. All done, I think. We're ready to save it. Please make sure you save your updated script.js file and then re-upload it into your S3 bucket, because your S3 bucket is still storing that old version and we're not gonna want that old version anymore. We're gonna say, hey S3, we've updated our JavaScript file. Please update the JavaScript file in the bucket too. So let's upload it. Great work. Now we're ready. Now we're ready to go into answering the question and seeing what's changed. To resolve the error, we updated script.js by by replacing some placeholder text with the prod stage URL with the API's prod stage invoke URL. We then re-uploaded script.js into S3 because the S3 bucket is still storing the last uploaded version, i.e. the version that's causing, i.e. with the error. I'll just make that shorter and we can click done. Congratulations. So that's your script.js all updated. High five to you. Great work. We've updated script.js and we've really set up that connection between our API and our website files. Let's get into the last step, everyone. We're going to validate that fully functioning web app. So can we search for items in the application now? Let us test our CloudFront site again and resolve an error on the browser side. So we do have one last error coming through that we can resolve together. So in this final step, we will test our CloudFront distributed site and then resolve one final error. I think we will test our CloudFront distributed site one more time because that's how we'll validate a valid connection between our API and the website files. We'll also run into a browser side error. We got this, okay? Don't lose hope. We're so close to the finish line. Okay, so let us head back into our CloudFront URL. Refresh the page. Enter that user ID. Get user data. No! We're still not seeing the user data. Yep, this is the browser side URL we were warning you about. Let's inspect it and figure out what went wrong. So head back into the console. And it looks like it is still failing to fetch. It is still referencing the old version of our, CloudFront distributed site with that placeholder, the prod stage API placeholder. So why is that? As we mentioned at the start of this project demo, CloudFront, one of its features is it will actually save that version of your distributed site into the different servers around the globe. So when you update your index.html file, what's really happening is it's not really, when you updated your JavaScript file, not index.html, what's really happening is it's updated the file within your S3 bucket, but it hasn't quite updated the file that's being copied into the servers around the world that's also serving you the distributed website. So how are we going to resolve this, team? We're going to need to resolve this. We're going to need to resolve this by... Okay, I noticed that the error message in this project guide is skipping to the next error. It doesn't quite address the error that we're seeing right now, which is seeing like the older version of our script.js file. So I'm gonna just freestyle this right now and guide us through this. So invalidations is the place where we go to force CloudFront to refresh the version of the file across all of its copies in all of the servers around the world. So we're going to create an invalidation, and we're going to say the object path is /, okay? We're going to go / and use the wildcard invalidation, which means / everything that's inside the S3 bucket, every file needs to be refreshed. If you want, you can go /script.js. And we can absolutely try that. So let us create that invalidation actually and see if that works. I'm not too sure if it would. I remember trying this once, and for some reason, script.js wouldn't invalidate by itself, and actually that might have been because of the object path reference I used. But I mean, let's try this. Let's try to invalidate script.js now and see what happens. All right, that actually worked. Oh my goodness, everyone. I was actually holding my breath there for a second because I wasn't sure if the script.js invalidation was going to work, but it did, everyone. So what we just did was we forced CloudFront to refresh the most updated version of the distributed website around the world. So now when you're actually viewing the website, you're going to see that you have a new error message, which is the error message we're supposed to see, okay? I'm going to actually just copy and paste a version, the distributed site URL into the chat if you're wanting to just check it out and just see the error for yourself. But I'm really excited to know that using invalidations worked perfectly just like that. And you can see we now have a new error message. It's no longer the same one with that prod stage API placeholder. It's a new one that's referencing failed to fetch user data. I'm gonna move myself away so you can see this properly. Failed to fetch user data, there's a type error, HTML button, on click, something's happening, okay, when you click on the button. That's okay. Let's solve this together now. Every error is somehow, in some way, fixable, all right? So we're going to fix this one together. Okay, so what is the error this time? Okay, this is the exact error that we saw. Okay, and actually, this error that we're looking at is called a course error, a C-O-R-S, course error. And you can find more about course by scrolling up in the error kind of feed, and you can see course policy, da-da-da-da. Okay, let's look at the simplified explanation for this. So what we're running into is called a course error. And a course error happens when API gateway is not configured to let CloudFront use the API invoke URL. What? How is that possible? Yeah, so the issue here is that we put that API gateway invoke URL. You see how we put it in our script.js file? We put it inside the JavaScript file. But what's happening here is by default, API gateway only allows requests directly in the browser. So it could only allow requests where you put it in the browser, press enter straight away. This is different from putting it inside our application code. Okay, this is different from like putting that same URL into here. Why? Because now it's not just anyone entering this API request directly. It's a CloudFront distributed site that's actually requesting to see or requesting the API or invoking the API. So API gateway says, nah, you're not allowed. By default, I'm only allowing requests that are sent directly through the browser URL. So what are we gonna do? Okay, to resolve this, you'll need to enable course on your API gateway so it can accept requests from the domain where your front end is hosted. Long story short, we need to go to API gateway, say, hey, let CloudFront be able to invoke your URL. Make sure it's not just like people entering it directly in the browser. They're not the only people that should be able to use this API. CloudFront should be able to use this API too. Okay, we're gonna have a stern word with our API gateway and make sure even CloudFront can use this API. So we're gonna take a screenshot of our console tab and we're going to upload that into our project guide. We ran into a second error after updating script.js. This was an error on the browser side with course. Because API gateway, by default, is only configured to allow requests directly run in the browser is only configured to allow requests from users directly running its invoke URL in the browser, i.e. not through CloudFront. So we need to give CloudFront the permission to run the API gateway's API URL too. I'm just going to write down a quick note on how maybe we can add a diagram to show this even better. And we're going to head back into API gateway and configure it so that we are enabling course. Okay, so we are enabling course, which is kind of like a VIP list of who is allowed to invoke this URL. You know, of course, people who are invoking it directly in the browser are allowed. Let's add CloudFront to that guest list, okay? So let's go to course inside the API gateway. select, I think it's select users first, and then you enable course. Okay. And then check both get and options under, whoop, make sure get and options are both checked here. And get basically means, we're allowing someone else to use the get method. Okay, and the get method is that API method that we set up that's actually connected to the Lambda function. So taking get basically means you're now allowed to get user data as well. Okay, so with the access control allow origin, this is the I guess this is the ID that's now allowed to invoke the API. So here we have our CloudFront distributed sites. Oh, I got lost in all of these different tabs. Apologies, team. But I'm gonna copy, okay, our CloudFront distributed sites URL, and I'm gonna edit it here. So this will now allow requests from your CloudFront domain to your API, and we're gonna select save. Thank you so much to Ariana in the chat. This is an awesome project. I lost a few years of my life dealing with course errors. I know, it's one of those pesky things. It's like, why? It doesn't directly go into like the developing of an application. It goes into like just making sure people can see it. And it really goes to show how cloud engineering is not really just about like knowing how to code and putting together an application. A lot of it also comes into like understanding the networking and the security, the hosting, cost management. There's so much you're taking care of. All right, team. So we've enabled course now. Great work. And let us actually talk about it in the project guide. So it goes into our documentation. So to resolve the course error, we first went into our API gateway, into our API, in API gateway, and enabled course on the user's resource. And we then made sure get requests are enabled and referenced our CloudFront domain as a domain getting access. Cool. So after enabling course, you must redeploy your API for the changes to take effect. So we need to go into our API and deploy it one more time into the prod stage so that, we need to deploy it one more time in the prod stage so that these changes actually reflect in our final distributed site. So let us click deploy. If we don't deploy, we won't be actually seeing those changes, those course changes take into effect. Great. Now that we have deployed that, one final thing is we need to actually add course headers in the Lambda function. I know, what an extra step to do. The API gateway is not the only thing to change. Now you need to change the Lambda function too. Oh my goodness, team. Isn't it so interesting how all of these different services are so intertwined, so interconnected? When you make one change, you can't just think of like the first service you might think of. You might also think about, what services are connected to that service that I'm changing. In this case, it's the Lambda function, because where does our API point to? It points to the Lambda function. So by adding course headers, we're kind of sorting out that connection between API and the distributed site. But now we need to also update the connection between the API and the Lambda function. So because we've enabled proxy integration, that was the toggle that we set up here. Let me show you. So that was this small toggle over here. We selected this, we turned it on, which meant that our Lambda function receives the entire kind of event that happens when you click on the Get User Data button here. What that means for us is now our Lambda function needs to actually be able to handle course headers as well. Now, course headers are added to the event, and it's also added to, and it also needs to be added to the response that Lambda returns, because the course headers is kind of like, you know how when you're added to a VIP guest list, maybe your name is on that that bouncer's kind of board that's like, okay, you can come in. But in some scenarios, what if the VIP is holding like this special band, or it has this special like hat to wear to kind of prove that it's a VIP. So in this case, Lambda really needs to include course headers in the response so that when API gateway passes that response back to the web app, back to the presentation tier, it's still wearing the hat, and it's still kind of showing that it has permission to invoke the API. So in our case, we still need to update our Lambda function, and we need to update it by changing the code to include the access control allow origin header in the response. So where can we actually find that? You can actually scroll down and see, look at that, access control allow origin star, access control allow origin star again. So you can see that we're now actually passing back the access control allow origin header into the response that Lambda pushes back. So let us head into our Lambda function, put that in here, and let us redeploy our Lambda function. Okay, team. So with that done, let's check in on our project again. What do we need to update? Ooh, check. Have you updated your region to your region's code? No, we haven't. And check for security best practice. Replace that star with your CloudFront domain name. Keeping access control allow origin means keeping access control allow origin as a star would mean you're allowing everyone to use your API. But that's not really what we want to do. We need to restrict access to just your CloudFront distribution. Cool. So let us go back into our code and make sure we've updated the region to US West 1, which is the region we're using in this demo, but updated to your region's code. And again, in that access control allow origin, change that star to something else, team. Let's change it to our CloudFront domain, CloudFront distributed sites domain, which is right over here. Okay, so copy that, okay, and update your function with that URL. All right, over here. All done. So we're gonna deploy our code one more time and take a screenshot of the updated function. So let's go and take a screenshot in the updated function. In fact, if you'd like, you could even make sure that the access control allow origin is mentioned in your code block. So we can style it like this. Take a screenshot like this. All right. And let us update our project documentation. Why did you update your Lambda function too? We also updated our Lambda function because it needs to be able to return course headers to show that it has the permission to invoke the API, invoke URL, and return a response. The changes we made were an update. The changes we made include updating the function code to our actually, I'm going to shorten this explanation by just mentioning we also updated our Lambda function code directly here because it needs to be able to return course headers to show that it has the permission to invoke the API's URL and return a response. Okay, so this meant, maybe we can say, I think we can say this meant adding access control allow origin as a header in we added access control allow origin as a header in the response. Phew! Finally, that was a tricky answer, wasn't it? Cool beans. So let's do a final test and refresh our site one more time and see what happens when we enter the user ID. Oh, do we deploy our function? I hope we did. Ooh, let's deploy it. So let us deploy our function code one more time. Ooh, so exciting. Oh my gosh. Deploy it. Ah, okay. So I think it means it's already deployed. But, oh no, I can see we still have an error. What's going on? So let's inspect again, head back into our console. All right, interesting error. I have never seen this error before, so we're doing this together now. Access to fetch the API from the origin has been blocked by course policy because the header has a value that is not equal to the supplied origin. Okay, well, shall we try to update our code one more time? Because what is in our API gateway? Let's investigate what is inside the API gateway and the course we've enabled. Well, we should be enabling course. Okay, and the access control allow origin should be here. .NET. Save that. Look at our function. Is it referencing the same thing? It should be. I wonder what's happened, team. Let us deploy this one more time. Again, we're running into an error I wasn't expecting. This is my first time seeing this error. Huh. It does seem to say that it's a matter of our course header not being equal to the supplied origin. Okay. Let's figure out what's happened. Let us close this. Huh, again. I wonder, do we need, I don't think we need to, I don't think it's because our CloudFront distributed site is not working. What could it be? Could it be? Should we just do a CloudFront, should we just do an invalidation in CloudFront anyway? I don't think this would be the reason though. If we were to invalidate CloudFront and serve the most updated version of the API. Do we deploy the API again? I'm pretty sure we did. Should we deploy it anyway? Oh, let's deploy it anyway. And see whether that was the cause. Huh. What was the reason? Refresh. Let's enter user ID 1. Oh no. What do we think is the reason for this error, everyone? It does say here that the access origin allow origin header has a value that is not equal to the supplied origin. I wonder why the supplied origin is not equal. Because it seems to have in course. I'm going to allow these to again enter the origin one more time. What do we think, team? What a interesting error. I am feeling a little bit confused about where this error would have come from. Let's keep thinking. Could it just be a matter of whether there's a slash at the end of the .NET? Could it be because of the slash? I'm so confused. Let me wonder. Shall we try just removing the slash from the end and seeing whether that works? Risky. Let's see. Let us enter a user ID again. Oh my goodness, it worked. It really was because of the slash. Oh, team, we ran into an error the second time because there was a slash in our function code. Oh my goodness, we really need to be careful, don't we, about the way that we enable, that we connect our services. The reason why I could think about the slash was because the only difference between because our CloudFront distributed sites URL was mentioned twice in the error message, once with a slash and once without a slash. So the first test is to just remove the slashes from Lambda, and the second test would have been to return the slashes but remove the slash in API Gateway. It really seems like that slash was the entire reason why just now there wasn't course error, because the headers weren't the same. I can really see how for Ariana you could lose a few years of your life dealing with course errors, because that was a very, very small detail there, but we managed to solve it, so well done. I'm glad to see that we have our final distributed site with a proof that it is connected to an API, a database at the back, and it looks wonderful. So what a win. Let us write a few more answers and wrap up the project for today. We verified the fixed connection between API Gateway and CloudFront by returning to the distributed site and looking up user data again. In our final test, user data could be returned. So a user request in the presentation here gets data from the data tier. Isn't that so cool? And that logic tier was the bridge between the two. I'm just going to shorten my answer. Nice. So we're going to select done. And we're going to delete our resources before we wrap up and before we go. So resources to delete. We have our CloudFront distribution. Do this first before the S3 bucket, the Lambda function, the API, and the DynamoDB table. So let's go into the distribution now, and let us select our distribution, okay, and select disable. Okay, so when you select disable, what's going to happen is it's going to take a few moments to fully disable the distribution across all of the servers. So it's going to take a bit of time before that delete button is going to come up. But you know what you could do, I'm not sure if this is going to work. It worked once. And what you could do is you could try and validate everything and see if it, yeah, no, it doesn't. I was really trying there, but it looks like it's a patience game with waiting until the delete button is available. So once that delete button is available, click delete and delete your distribution right away. So something else we could do is to delete the S3 bucket. Usually, please delete your CloudFront distribution first before the bucket. So let's move on to the next thing, which is our Lambda function. So let's go into Lambda, select the function, delete it, and we're done. So satisfying to know that all parts of our three-tier architecture has worked swimmingly well, so well. And now we get the satisfaction of deleting all these resources, knowing that we know how to do it all from scratch again, you know, next time. So let's delete our API as well. Confirm our deletion. Well done. Delete that. And finally, the DynamoDB table. So let us select our table and delete that too. So please leave these default ticks just to minimize any charges, because if you tick this, that's a charge. If you untick this, that's also a charge. So tick the first one, untick the next one, and confirm before you finish off and delete it. Now, CloudFront distributions take a bit of time to delete. So what I'm gonna expect is that it might take a bit of time before we can actually see that delete button. So I'm gonna see now if there's another distribution I could delete. Doesn't seem like it. We'll have to just leave this be, and in the meantime move on to the next part before we might come back to delete everything. But if we don't get to cover that in this live, just know that you simply have to delete the distribution and empty your S3 bucket, delete everything inside, and you should be all sorted. Okay? Let's do our final recap for the project today, and let's talk about it. Before we do that, let's see, we have another question about whether this will be on YouTube, and yes, it definitely will be. Please check out our YouTube channel. It's called NextWork, and it should be inside the live tab. So services we used were so many: Amazon S3, CloudFront, DynamoDB, Lambda API gateway as well. Key concepts we learned include Lambda functions, course errors, connecting, updating the API invoke URL, updating the JavaScript file, with the API invoke URL. And I think that's the key ones. Those are pretty key. Plus, and testing the invoke URL within the browser. That was something else we could do, just to purely see the connection between the API and the data tier. Oh my goodness, that was pretty loud, wasn't it? Sorry about that, team. And final two questions. How long did it take us to complete the project? This project took us approximately 2.5 hours, including demo time. The most challenging part was definitely resolving the course errors for myself, but what about you? What do you think was the most challenging part? I would love to hear it. So we had to resolve it in both API Gateway and Lambda. It was most rewarding to see the final outcome. Data getting returned in our web app. Great work. So we did this project today. To learn about the 3-tier architecture and set up our own web app. This project absolutely met our goals, and we could see a fully functioning web app by the end. So good. It's even connected to an API. There's a Lambda function. It retrieves data from DynamoDB. What a win. Great work. So that's a wrap. You've built a 3-tier web application on AWS. That's a huge accomplishment. Give yourself a pat on the back or a high five to your computer screen. I think that could work too. And be really, really proud of all the things you've just learned. Storing website files with S3 was the beginning, and we went all the way into delivering content with CloudFront, writing the code with Lambda, which we later updated, creating and managing APIs with API Gateway, and then also DynamoDB. So thank you so much for joining me in this project, and let us select mission accomplished together. Whew, amazing. That mission is accomplished. Congratulations, everyone. hang tight. The documentation is on the way. I'm going to move my face away so you can see the whole bar. And let us download the documentation now. Great stuff. Okay, we've downloaded the documentation. We can see it in action here. It looks so beautiful. Congratulations. Presentation tier, logic tier, data tier, the logic and data tier, console errors, resolving the course errors, a fixed solution. Wow, it looks amazing. You have done an amazing job sticking through this entire project, writing up your documentation, solving some unexpected errors together, and let us share the project on LinkedIn. So I'm gonna click on that share on LinkedIn button, and let's see, we have a pre-filled post that you can use. Just deselect that pop-up or that little pop-up URL, and let us tag NextWork in our post so that we get notified and your post reaches more people. Again, let's remove that pop-up. Oh my goodness, so pesky. And let us add a document to our post. So as you guessed, we're gonna add our 3-tier architecture web app documentation. And here we are, all done. Great stuff, everyone. That was amazing. You should be so proud of yourself, and you can select done when you're ready. Now, I'm going to just quickly double check whether our CloudFront distribution can be deleted, and yes, it can. So in that time where we wrapped up the project, the CloudFront distribution is definitely ready to delete, which means we can also delete all the files inside our S3 bucket and delete the S3 bucket itself. So let us delete the S3 bucket and delete the S3 bucket itself. I'm so glad we can do this live together because it really is a project wrapped up now. So let's delete it. All done. Thank you so much. Well, that is a wrap for today's project. If you have any questions, you can add it to the comments or you can add it to the NextWork community. We'll be right there. And we'll see you in the next project. And I hope you have a lovely rest of your day. Thank you, team. It has been an amazing time doing this project with you. You've absolutely made it such a vibe. And to anyone that's asking when there will be another live demo, there will be one every single week at the exact same time, so this time. And hopefully we can work towards 2 project demos a week in the next few months. So thank you, and we'll catch you in the next one. All right, bye everyone. See ya.